Okay, so this is going to be a quick demo of my final year project. My final year project was to create some dependency analysis and test smell detection for Gauge test suites. So Gauge is a natural language behavior driven development test framework. What that essentially means is write your tests as a series of steps in plain English. So they'll look something like this. So the test that the user sends an email, the first login, knowing how many messages have already sent, compose an email and send it. The number of sent messages is increased by one, and then the log out. So each of these is either some code backing it up, or it can be another series of steps. So the aim of this project is to take these markdown files and generate a dependency graph of them. So for instance, the user sends email test will depend on the login step. The login step depends on the test user email is, test user password, and so on. So the main point of this tool was to initially develop a tool capable of visualizing these relationships to be able to conduct dependency analysis, and then using those dependency graphs to identify and highlight test smells to improve code quality within the Gauge tests. So there are two ways that this tool can be executed. One is just simply from the command line. So if I do Python dependency graph, and then I pointed towards a folder of Gauge tests. So this this folder here, and it doesn't matter what the folder structure is. So what this will do is generate a dependency graph and highlight all test mails with just the default settings, and then open it up in a browser window here. So because this is quite a large file, it does take a second to load. So this is one that's already loaded. We can see there are scenarios, concepts, and steps. So I'll just quickly move on because it'll be a bit clearer once I show the GUI for the system. So if instead I do Python main.py, this will bring up our GUI interface. So I'll actually just create. So if I click this browse button, it'll bring up a Windows Explorer, and I grab that same folder again. And if I click parse now, you can see this is what parse through this folder and all of its subfolders and populated this list with all of the Gauge files that it's found. So I can then click draw graph, and this will draw that graph that you've seen there previously for every single file here. Now you can also draw graphs for individual files or any combination of files. It's also configurable. So this node here shows you which source file that these tests came from. You mightn't necessarily want to see that, so that is configurable. So if I just, and then there's a bunch of other configuration points to do with spacing, because depending on the layout of the graph, it can be a bit weird to get the spacing correctly. So if I just grab all of these again, instead of drawing the graph, we now detect the test smells on it. This will again draw out the dependency graph, but this time it will highlight any nodes that contain a test smell. So, for instance, a test that has too many steps, it has a really long name, it's not being used, or it's referencing itself. So we'll see that here in a wee second once this loads. Okay, so here we have that same graph again with the test smells highlighted. So obviously the ones in red are the nodes that contain smells. So any one we hover over here, we can see what the smell is. So you can see these ones, these concepts, which are groups of steps, aren't actually being used anywhere. Or for instance, this this slot. step name is over 120 characters, which could be considered a smell. Grab, it's too many steps. Yeah, so this one that has over 10 steps is also an unused concept. So as you can see there, it can be a bit, while this is a good view to give you an overall sort of health of your test suite, it can be a bit difficult to pinpoint where things are. That's why we have this generate smell report button, which instead of highlighting nodes on the graphs, generates this report, which will go through each of the currently supported smells and report the number of instances, and then show a subgraph for each smell. This means, so say if you had a test code engineer had a task to get rid of all the long test smells, they could use this report, and it would be a lot easier than looking at the previous graph to try and determine, oh, this one has a long test smell with potentially lots of different nodes have lots of different smells, and some of them have multiple smells. So, one last thing, you're also able to save the graph. So, if I previously saved this, so we're able to save that up. You can see this is just previously the same thing we've seen before, being able to open it in a web browser. So, just sort of to finish off, talk about what was the most technically difficult thing implementing this project, and I think that's quite a difficult question because I feel as if the technical difficulty throughout this project was fairly consistent, so it's hard to pick one thing that stood out as particularly difficult. But I would have to say it would probably be getting all the different frameworks to work together correctly. So the way these graphs are generated is each of these files here actually has a YAML file associated with it. So something like this, it stores all the information about that. And then whenever these are checked, it grabs all of those all of the checked YAML files and combines them and then generates this visualization. But the underlying YAML format and the visualization framework are two separate frameworks. And while they are supposed to have interoperability together, and in fairness, they do, it wasn't quite at the level I needed because obviously there's a lot of conditional formatting needs to go on with like smell nodes and scenario nodes and step nodes and so on. So I end up having to rewrite a lot of that logic that is supposed to integrate these two frameworks and just do that from scratch myself to suit my needs. Another difficult thing was the processing of the markdown. So a lot of gauge tests will have stuff like this. They'll have comments, tags, and other stuff that aren't necessarily part of the test. So obviously they need to be removed before it can be properly parsed. So that led to the creation of this class, which basically uses a lot of regex to get rid of that. And obviously not a great solution because regex can get out of hand very quickly the more edge cases you have, and that was certainly the case there, where it started off quite simple, and then the more test suites we had, the more complex it had to grow to cope with all of the different edge cases. So I think if I was doing this again, I would find a better solution than regex for all of that. Also, speaking of further improvements, obviously the next logical step in this is to continue adding more and more test smells. The only really way to do that is to work with people who are working on these test suites and find out what are the pain points they're constantly experiencing, what do they believe are the test smells that will help them write better tests. And also probably would like to make the a bit more modern looking, but I think for the purposes of this, it's good enough, but it is a bit basic. And also these options, currently if I change any of these changes aren't actually persisted. So if I close this application and open it again, it won't have the same options that the real reason that wasn't implemented was due to time constraints. So I believe that is just about my time up. So thank you very much for your time and listening to this, and hopefully what I said just made sense. Cheers.